All right, what follows is a summary of what we discussed in class. The ultimate goal here is to learn how to effectively use the graphing calculators that we've paid so much for. And understand that just typing things into a calculator is not going to give us the results that we need. We have to understand what we're doing, we have to anticipate our outcomes, and then the calculator use will be effective and efficient. So what I'm trying to avoid here is using the calculator, or learning how to use the calculator using guessing check methods. That works when we're playing video games, but it doesn't really work when we're trying to learn. So we need to think a little bit first. So here's the problem that we're encountering. We have this box, and it has a square base, and it's going to have a volume of 200 cubic centimeters. So this is just some facts about the shape that we're dealing with. Turns out I can explore the surface area, that's the amount of paper required to cover the box, and that will depend on how long the base of the box is, according to some equation. So apparently if I take 800 divided by x and I add 2x squared, that whatever the length of the box is, I put that here and here, and that will tell me how much area is required to make the box. So it's a convenient little formula. But I need to know more about this before I can just type it into my calculator, hit the graph button, and see what I want to see. Because I did that. I entered into the calculator the equation in the calculator language that I saw right here. Put that in the y equals, and I hit the graph button, and this is the graph that I saw. And so it shows that for negative x's I have some negative surface areas down here and some positive, but this isn't what I want. There has to be something going on in the first quadrant. So I need to think a little bit about the variables. First of all, I'm careful to identify my independent variable. My independent variable in this case is going to be the length of the side of the box. I know that because that's defined as x, which is here in the independent variable position. Dependent variable then is the area, and so what I get is the area is going to change as I change the value of x, even though the volume will be fixed at 200. So I ask myself questions what kind of numbers should I expect in the domain? For example, big numbers, small numbers, positive numbers, negative numbers. What kinds of numbers are reasonable or even possible in a situation such as this? So when I think about that, I first already can throw off the negative numbers because we're talking about length of the base. We're not going to have a negative length for the base of a box. So negative numbers, they're off the table. So here in my graphing calculator, I show negative x's on the number line. I don't need to see those. That's not part of my needed information. So let's talk about big numbers, gigantic numbers. If we made x too big, then it would be very difficult to make a box that holds 200 cubic centimeters. For example, if I had a box whose length was 200, then because it's a square-based box, the width would also be 200, and there would have to be some height. And in the end, I have to make a box that holds only 200 cubic centimeters. Well, here I can see volume will be equal to, sorry, this is really sloppy, let me fix this. Volume will be equal to 200 times 200 times the height. And since the volume itself has to be 200, we can recognize that, divide both sides by 200, and we will learn eventually that h has to be 1 over 200 centimeters. So that's 2 millimeters, I think, if I remember my math. I'm not so good with numbers. But anyway, the height of this box would be so unreasonably small that we wouldn't even really consider it. So we don't want our x values to be negative. We also don't want our x values to be too large. So let me erase some of this stuff here. Actually, I could just do that. There. The other thing that we can do when thinking about the domain is think about context clues. So when I read the entire problem, after I scan the whole problem, I see in part B it asks me to evaluate a of 5. That's saying x is 5, and that tells me then my x's should be reasonably small numbers in order to get surface areas of reasonably shaped boxes. So then I'm going to use the best guess for my domain to understand the range. What I mean by that is I now know that we're going to use small positive numbers for my domain, but I don't know how that's going to affect my surface area. Am I going to get large numbers for my surface area? Really small? What are those numbers going to be like? That's where the technology comes into play. I can use my graphing calculator. I go to y equals, and I can enter in the function equation as shown. And Then I go to table settings. To get to your table setup, you hit the second, or the shift button, that's the second function key, and then you hit the window button, and here you can see where it says table settings. You get the table setup, and you can change the where you start the x values and how much the x values are going to change by. Here it should be 0. I want to start at x equals 0, and then I want to go up by 1s. Once I hit the table, and to do that I will hit the second function and then the graph button, and that's how I get the table itself. Here I see a table of values. Each of these numbers here was achieved by taking the x value corresponding to it and substituting it into this formula to produce a specific surface area. Now, in examining these numbers, I see that, first of all, if there was 0 length for the base, there's really no surface area because there's not a shape to cover. But if the length of the base was 1, it would require a lot of surface area relative to if the base was 4 units in length. It only requires a quarter almost of how much surface area was required before. Anyway, observation of these numbers tell me, first of all, my surface areas are going to be much larger than my side lengths. My surface areas here are in the 2 to 800 range. So these are the kinds of numbers that I find to be interesting, and I see that if I go much past 10, I'm going to get surface areas that are larger than desirable. So what I do is I set a viewing window so that I see only the x-axis, so the part of the x-axis that matters to me. I think it's between like 1 and 12. So 0 and 12, so I put -1 to 13 to give myself a little room on either side of the x-axis. This scale here says count by 1s, and by the way, to get here you do hit second, or actually not even second, you just hit the window button, and that's why you get your window settings right in here. The minimum y value is -25. Now I do that just so I can see where the x-axis is, and then I put in for my maximum, in this case I put 600, which is maybe a little high, but I wanted to see a lot of different y values displayed on the calculator. Once I hit the graph button, which is right here, I end up with a picture that looks something like this. So this shows a variety of different surface areas depending on the length of x, going all the way up to 13 centimeters. So what I've done is I've found a graph, but in order to find the graph I had to A, learn how to use the calculator, and B, understand what kind of numbers I should be putting into the calculator to be able to see what I need to see. Now I went really fast there. If you didn't catch all that, go back and watch it and pause once in a while and think about what I'm saying. One last thing I'm going to talk about here is I didn't even get to answering the question yet. I spent all of my time thinking to understand, to make sure that I know what's supposed to be happening. There's one other thing that I can do here, and that is I can go to the calculate button, which I hit second, trace, to get the calculate options, and I can calculate a value of a function. When I do that, if I just type in x equals 2, the calculator will show me where on the graph that exists. So here's x equals 2, I follow it up, and it shows me the y value that corresponds. I get more data every time I hit a different x value. It's going to tell me the specific location on the graph and the corresponding y value for that x. And so I found 3 specific values. Those 3 values are going to help me draw a graph. That's what I have to do in part A, and that'll be in the second part of this video series. Have a great day.